Just check if I've done it again. இப்ப பாருங்க தெரியுதா? Are you able to see? Can you see now, Maithili? Just see if you can see the PPT now. Maithili? Fine, let's take this. When pi is equal to 12 by 342 into 1000 by 100. R வந்து என்ன எடுக்கலாம் 0.0821. Temperature வந்து 273 plus 17 degrees வந்து 290 ஆகும் into 290. Calculate பண்ணி பாருங்க எவ்வளவு வருதுன்னு. Are you still finding it the same way, Maithili? So just see this. How much will we get? 8.35 atmosphere. Could you hear my voice, Maithili, till now, or even that you couldn't hear? Shall I do it from the beginning in that case? A solution of 30 grams of urea in 1 liter at a certain temperature is isotonic. Isotonic and they have same osmotic pressure. Urea and unknown substance. So osmotic pressure of urea and osmotic pressure of X is same. 30 grams of urea and 1 liter of water at a certain temperature is isotonic with 18 grams of substance. Temperature, they didn't give anything about temperature, it means the temperature is same. What is osmotic pressure equal to? CRT. So CRT of urea should be equal to CRT of some X. R and T வந்து நம்ம constant. We have to say C of urea is equal to C of X. So concentration எதுல கொடுக்கலாம்? We will go with molarity. So molarity வந்து N by V. Volume of solution வந்து ரெண்டுக்குமே they have given us 1 liter of solution. So we will not take even volume, you can directly compare with number of moles. So urea வந்து 30, we have already done the molecular weight of urea, it's 60 is equal to 18 by X. X என்ன ஆகும்? X will be equal to 18 into 60 by 30. So என்ன வருமா? 18 2s is 36. Molar, இது புரிஞ்சுதாமா மைத்திலி? Fine. Shall I go back to some of the slides and explain you the same? We have time. No, I'll just do it a little faster. See, we have certain properties called as colligative properties. Colligative properties and என்ன சொல்லுவாங்க? நம்ம ஏதாவது dilute solutionல if the properties depend on the number of particles and not the nature. எவ்வளவு particles இருக்குன்னா, like if I take NaCl, NaCl will give me Na plus and Cl minus 2 particles. If I take MgCl2, MgCl2 will give us, I mean in aqueous solution, if I take in the solvent water, it will give us Mg plus 2 chloride ion particles எவ்வளவு வருதுங்க 3, இங்க வந்து 2. If I take urea in water, it will not split up, number of particles is same, one only. So there are certain properties which will depend only on the number of particles and not the nature. இது என்ன? What is it? Type of substance. They don't depend on the type, but they only depend on the number of particles. Such properties என்ன சொல்லுவாங்க? Colligative properties ன்னு சொல்லுவோம். And we generally take it for a very dilute solution. அதுல வந்து நம்மளுக்கு one of the properties relative lowering of vapor pressure. Relative lowering of vapor pressure என்னன்னா சொல்லுவாங்க? Reduction in the vapor pressure with respect to the pure solvent வந்து we are talking it as relative lowering of vapor pressure. PA naught and என்ன vapor pressure of pure vapor pressure of pure solvent. PA வந்து vapor pressure of A in the solution. So when we add solute particles, என்ன ஆகும்? It will take moment. If you heat it only, then the vapor pressure, like if I take a liquid, pure liquid is all the surface is made up of the molecules. And Maitli, you are able to see that clearly. Now, shall I continue? Fine. Vapor pressure of pure solvent minus the vapor pressure of solution will give us a difference. When we divide it by PA naught, it will become the relative lowering of vapor pressure. And this relative lowering of vapor pressure is equal to the mole fraction of solute. The relative lowering of vapor pressure is equal to mole fraction of solute. Mole fraction of solute and number of moles of solute by total number of moles of solution. Since we are taking dilute, dilute solutions, what we will do is number of moles of solute can be neglected in the denominator. So PA naught minus PA by PA naught is equal to NB by NA for a dilute solution. Number of moles of solute and weight of the solute by molecular weight. Number of moles of solvent weight by molecular weight at reverse circle. See, the question is given: a solution of urea in water is prepared by adding 180 grams of urea solute, 1800 grams of solvent. So how do I write? What is the relative lowering of vapor pressure? PA naught minus PA by PA naught is equal to mole fraction of solute. Since it's a dilute solution, direct away we can take NB by NA. NB and weight of solute by molecular weight of solute into molecular weight of solvent by weight of solvent. Weight of solute enna kuduthirukanga 180. Molecular weight of urea 60. I have written it here how to calculate. Into water solvent. So 18 by 1800. This I can directly divide it by 100. 60 goes 3 times. So 3 by 100 வந்து நம்ம 0.03. புரியுதுமா மைத்லி and aditya irkara? Only Maithliya. Maithli, are you able to understand? Shall I continue? Fine. I was telling you about the colligative properties which depend on number of particles and not on the nature of particles. We call them as colligative properties. Relative lowering of vapor pressure, elevation and boiling point, depression and freezing point, osmotic pressure. Relative lowering of vapor pressure and reduction in the vapor pressure of solvent when a non-volatile solute is added as relative lowering of vapor pressure. What is elevation and boiling point? Increase in the boiling point when we add a non-volatile solute. Freezing point ennaagum kammi agum. Boiling point jaasti agum. Idu ellame namakku colligative properties and very very important for us. So a graph is drawn between vapor pressure of the solvent and the solution with respect to temperature. So, and when do we call it as boiling point? When vapor pressure of a liquid is equal to the atmospheric pressure. My the doubt irka? So solvent oda vapor pressure namakku jastiya irukum. Red color the solvent. So its boiling point is given as TB naught. So when we add a non-volatile solute, you will have to heat it to a higher temperature for the vapor pressure to become the atmospheric pressure. So boiling point of solution on the jasti atom. The difference between the vapor pressure, boiling point of pure solvent and the solution on the delta TB and solvom. Elevation and boiling point. That depends on the molality of solution. more the molality, more will be the elevation and boiling point. If I have to remove this proportionality constant, enna paranum ஒரு constant கொண்டு வரணும். என்னது constant? We call it as molar elevation constant or ebullioscopic constant. Molar elevation constant illana ebullioscopic constant. The unit of Kb is Kelvin kg per mole. Depression in freezing point and நம்ம freezing point வந்து கம்மியாகுது. என்ன பண்ணுவாங்க இப்ப? So like in case in cold countries, what happens is we get ice is formed on the roads. Ice form ஆகும்போது என்ன பண்ணுவாங்க? So to prevent the formation of ice when it becomes 0 degrees, நமக்கு sodium chloride and calcium chloride வந்து road மேல போடுவாங்க. போட்டா என்ன ஆகும்? It will freeze, but it will freeze at a lower temperature below 0 degrees. So that's what we are taking of the freezing point. Liquid is becoming a solid. The orange color of the pure solvent on the liquid state la irukku. When you bring down the temperature, it is frozen. The point at which the solution or the freezing point strikes the solvent, that will be the freezing point of solution. Freezing point of pure solvent will be more than that of the freezing point of solution. The difference again is called as delta Tf. Delta Tf is directly proportional to molality of solution. So delta Tf on the Kf into m. So I have written here the units of Kf. Kf will be delta Tf by m. Molality or units in moles per kg. Delta Tf on the temperature difference, then we will take only Kelvin. என்ன சொல்வோம்? KFI we will call it as molar depression constant or cryoscopic constant. So cold countries, I was telling you this only, that on the roadside they add sodium chloride or calcium chloride to reduce the freezing point from 0 degrees to much lower, so that ice is not formed on the roads. Ice cream parlor, if you go even there, they do the same thing. So that the ice does not melt, what they do is on the sides they add some salt so that they can keep the temperature below 0 degrees. இன்னொரு problem என்ன இருக்கும்? Car radiators, water வந்து freeze ஆகிடும். So to prevent the freezing, they add ethylene glycol. The relation between the molar elevation constant and the boiling point, Kb is equal to RTB naught square by 1000 LV. LV and latent heat of vaporization. The amount of heat required to raise the temperature of 1 gram of a solvent, we call it as latent heat. If we take for 1 mole of a substance, நம்ம என்ன சொல்லுவோம்? Enthalpy of vaporization. அது எப்படி இருக்கும்? Kb is equal to R universal gas constant into TB naught boiling point of pure solvent by 1000 into LV. If we take it for 1 mole, we will write it as M R TB naught square by 1000 into delta H vaporization. If I take in place of delta TB TF, we will call it as KF, the constant. Only difference is enthalpy of vaporization, we take it for molar elevation constant. Enthalpy of fusion, we take it for molar depression constant. The problem parma, if freezing point of solution of 1.25 grams of electrolyte and 20 grams of water is 271, what is the molar mass of the solute? Delta TF on the freezing point of solvent jastiya irukum when compared to freezing point of solution. And we know if water is the solvent, freezing point of water at 1 atmosphere is 273 Kelvin. 273 Kelvin minus solution or freezing point கொடுத்திருக்காங்க எவ்வளவு 271.1 is equal to Kf into molarity என்ன பண்ணுவோம்? How do we write molarity? Weight by molecular weight into 1000 by weight of solvent in kg. பாருங்க, I substituted everything. Kf வந்து நம்மளுக்கு கொடுத்திருக்காங்க 1.86, solute 1.25 grams. They asked us the molecular weight, solvent oda weight 20 grams கொடுத்திருக்காங்க. Substitute பண்ணி calculate பண்ணா what we get is 105.68 வரும். So you can see that osmosis and enema, the spontaneous movement of particles from one solution to another solution, from high concentrated solution to less concentrated solution, we call it as osmosis. And if we prevent this flow of solvent particles through a semi-permeable membrane by applying a pressure, we will call it as osmotic pressure. Generally, we will take a semi-permeable membrane. Semi-permeable membrane is a membrane which will allow only certain particles to flow through it. We call it as a semi-permeable membrane. So, when solvent molecules move from pure solvent to a solution through a semi-permeable membrane, we call it as osmosis. What are the examples of semi-permeable membrane? One is parchment paper, copper ferrocyanate, calcium phosphate, phenol saturated with water. Remember the examples. Now, if we apply some pressure to prevent the flow of water from a dilute solution to concentrated or from solvent to solution, we call it as what is called as osmotic pressure. Osmotic pressure is given by pi. Pi is equal to CRT, where here we are taking the concentration as molarity. Elevation in boiling point, depression in freezing point, we will take it in terms of molarity. இங்க வந்து molarity எடுக்கலாம், molarity எடுக்கலாம். So we have three different types of solutions: isotonic, hypertonic, and hypotonic solution. Isotonic solutions are when the osmotic pressure of two liquids is same. So when we go to hospital, what happens is they give us intravenous and a saline கொடுப்பாங்க. Saline ஓட osmotic pressure நம்ம blood ஓட osmotic pressure same இருக்கும். What saline is given? 0.9% mass by volume sodium chloride கொடுப்பாங்க, which is called as a saline water. The osmotic pressure of saline water and our blood is same. We call such a solution as isotonic solution. Instead of that, if we take a higher concentrated solution, அப்போ என்ன ஆகும்? நம்ம bloodல இருக்கிற liquid வந்து it goes into the saline water. What will happen? The cell will start shrinking. Such a solution we call it as hypertonic. If it happens the other way around, if you take a less concentrated solution, what will happen? Water from the liquid will go into the blood and it will make the cells to swell up. Such swelling up will happen when we take a hypotonic solution. Maythili puriyadamma ellame. Exosmosis, endosmosis, almost the same ah irukum. Outward flow of water or solvent from a cell through a semi-permeable membrane. We call it as exosmosis. Endosmosis and if it comes inward flow of water or solvent from a cell through a semi-permeable membrane, we call it as endoosmosis. Right? hypertonic solution enna solution same higher than that of the solution from which it is separated, we call it as hypertonic. Now சொன்னது if you put, if I take a plant example and we add a more concentrated solution, என்ன ஆகும், பிளான்ட்ல இருக்கிற வாட்டர் எல்லாமே வெளியில வந்துடும். It results in what is called as plasmolysis. அதுல இருக்கிற fluid எல்லாம் break ஆகுறதுனால we call it as plasmolysis. எப்ப ஆகும், when you keep it in a higher concentrated solution. A less concentrated solutionல போட்டா என்ன ஆகும், it will swell up. So number வீட்ல like in home we use what is called as reverse osmosis. Normal osmotic pressure ல என்ன ஆகுது, water is moving from diluted solution to concentrated solution. நம்ம reverse osmosis ல என்ன பண்றோம், we are applying a pressure such that water moves from a high concentrated solution to a less concentrated solution. We apply the process of reverse osmosis. That is, when we apply a pressure higher than the osmotic pressure of the liquid, what happens, water will move from high concentrated solution to a less concentrated solution. Again we are taking a semi-permeable membrane. Such process we call it as reverse osmosis. We use the same thing in our home, we call it as RO. It works in the same process. In the problem you were Maithili the Pathiya any problem 8.35, were you there, you want me to repeat it? Or shall we stop it here, because other example I know you were there. I think there was an issue with internet for both of us, I guess, because I know sometimes I think my system, you couldn't see the video, I couldn't see the messages. Fine ma, thank you. Let's meet on Friday. Thank you very much. Very simple topic, interesting because it's more application oriented.